meeting on Wednesday. I didn't really think there was a need for it since you were not in class and everybody else does this by podcast. I figured I'd just send an email out and tell them to keep working. So let's see, what am I supposed to be doing here? But today we're going to really kind of look at the last part of our work here, our worksheet rather. And there it is. Okay. So, we started off with doing the first 8 or 9 pages of this, and I've received the alternative designs, and that's good. Did you turn in your final design to me? I thought I saw an email. Okay, that must be from somebody else. I couldn't remember who it was. But that's what we're going to talk about today. We're going to talk about how to submit the final design and get started building and actually carrying out your final design. So at the bottom of each of your alternative design evaluations, or design sheets, you should have done the alternative design evaluation. And this is really the key to this next step for the final design. Each one of your evaluations you will give a score to, depending on how they meet the requirements, how you think they will function, how they look, and what their economy is like. So economy meaning how much material you use. To use more material, it's worse. To use less material, it's better. And so once you have done that, and you have drawn your alternative designs, you're going to put together a scale drawing of your final design. And this one is going to be a little more detailed. So we start off with just a very simple design where it's kind of like a little pencil sketch of each one of these members. But then as we get further into it, we're actually going to include what members are made of what materials, and we're going to actually write down all the exact materials we need to use and any other information that we need to put in there, where holes are going to be drilled and where other things are going to be connected. And we want this drawing to be very, very much to scale, so that you have a very specific scale that is labeled on your sheet, and your drawing has all of the parts, their correct lengths, at their correct angles, with the correct connections and everything else, as close as you possibly can. Now they give us a few tools for this, because sometimes it's difficult to know exactly how long these things are going to be in the end. You can use a scaled ruler. For example, if 1 centimeter on your scale is going to equal 1 inch in the real world or something like that, then you can just use the centimeters on your ruler to measure inches. Or you can also, in the case of right triangles, you can use the Pythagorean theorem to calculate angles. And if you're not familiar with that, it's not terribly difficult. You just have to go in here and make right triangles. For example, if I wanted to know how much this member 8 over here, how long that was, then I would make a right triangle by going from the peak of that member 8 down to the base here, and then I could count the squares from base to peak and get a length for side E, and then I could count the squares on the bottom from this tip out here to where the line comes down, and get a number for D, get a length for D. And then I could use this formula, d squared plus e squared equals f squared, to calculate the third side f. And it's a fairly simple formula, and hopefully you've used it before. But you should specifically be listing the exact pieces that you're going to use. Now, most of your bridge is likely to be wood. You don't have very many plastic pieces. You can use them if you want, but the wood is actually much stronger and much stiffer too, so it won't bend so much. And you have a sheet for plastic and a sheet for cable. And if you have any other items that you're going to use in your bridge, if you're going to use some bolts or if you're going to use some string or something else, then just list those at the bottom one of these. Make sure that it's known that we're now listing cardboard sheets, because I gave you some cardboard sheets or whatever else. So that is what you've got there. Once you have, once you've started this kind of simple layout drawing, eventually I would like to see a more detailed drawing. And I'm not sure if they show one here. I'm looking to see if they actually show one as an example. Doesn't look like they do. But you've got, down here at the very end, you've got this extra big sheet, which is actually 4 sheets in one. So you can print off all 4 of these sheets and kind of tape them together for your drawing. And then draw on them as a wide horizontal sheet. And then once you've done that, you've got more room to be a little more accurate or a little more realistic with your drawing. And I would like you to do that as much as you can. I would like you to use the actual thickness of your beams and show the actual thickness of your beams, so it's not just a stick drawing anymore. I would like you to show where bolts are, so you should label your drawing. Like if you have 7 spots where you're bolting things together, then label those spots with like maybe a little A or a little B or something, and then off the side have a key that says B is equal to a 1/4 inch bolt or a 1/2 inch bolt or something, and so on and so forth. Just some. I want everything that is going to be on your bridge, every little piece, to be on the drawing and drawn with as much detail as you can without it being messy, and also labeled very clearly. Here in the end, you can see that they have labeled many things. They've got labels for different lengths. So this is 9C, for example, here. This is 13C and 15C. Well, C are all wire cables, right? And then they have over here, they have 3, 4, 5, 6, those numbers up there. And they those are going to be wood because they have no other label besides just the number. And then they don't have any plastic in there. So anyway, they've got a key up here for the labels that they put on their drawing. And that's the kind of thing that I would hope that you would have on there. Now, once you are done with the drawing and with the calculating and with the entering of all the different sizes of things that you're going to put in here, these lists should have every single part that you're going to use for your bridge. And so you should start to build it once you've got that done. Now I do want you to turn in your final drawing, your final design drawing to me before you start building. And while you're building and testing, if you make any changes at all, you should immediately make a new drawing or update your old drawing and send me a copy of your new drawing. If you make a change, I want to know about it before it's done. And it's very likely you'll make changes. You'll find out that one part of your design didn't quite work out, and it's weaker than you wanted it to be, or it's just not functional. So you change something, you add something, or you modify something. And that's perfectly fine, but you need to make the changes to your drawings, and you need to get those to me. And then you start measuring and cutting and putting aside all the parts that you need. You should measure and cut everything that you're using and have it all ready before you start building. And the whole time you're doing your building process, I really would like you to take pictures of the process. So when you have finished measuring and cutting everything, take a picture. When you've started putting things together, maybe after your first hour or your first day of building and you're not quite done, take a picture of your progress. And keep a little picture diary, a little photo diary of what you've done, and you will turn that in at the end of the process when we're all done with this worksheet. And then they talk about using a certain size bit to drill holes with. What I would do is I would use a bit that is just barely the size of the dowels if you're going to be using dowels, or just barely the size of the bolts if you're going to be using bolts, or whatever else, so that whatever you put in there has a little bit of friction, so that things are not just rolling around. You want a little bit of friction in there to really be effective. They give you some tips and pointers about how to do that, and some ideas on how to prevent the wood from cracking, because the wood can crack easily if you're drilling through small pieces of wood with a drill. Don't push really hard. Let the drill do the work, and just drill nice and easy through the wood. You want the drill to be moving fast, but you don't want to push it fast through the wood. So that's an important help there. When it comes to glue, I would highly recommend that you should glue things that need to be glued a day ahead of time, and then start putting them together with other things. You shouldn't put any stress on a glued member of your bridge before you have let it cure overnight. Also, they show a nice little process here for making I-beams. I-beams are extremely strong, and you can make them lots of different lengths, so that you can use a single structure at the bottom of your bridge that is very strong and very light, and essentially just glued together. And then it's just assembly time. As you're assembling, once again, please take some pictures, make a little photo journal of what you're doing, and then you'll be done. At this point, once you're done with your bridge, it is time to test it. Remember that the requirements of the bridge, that it be 18 inches wide, that it can span a gap that is 18 inches, but also that it can hold a load. And the load should be, I think we said 5 pounds or 2 pounds, whatever we said. Let's go back to the beginning here. It says 2-pound load at the center, but you should probably try to test a little bit higher than that. Your testing is your final grade for this project. As you get down here towards the end, you have this little report, this post-test bridge evaluation. And they're going to talk about design efficiency, which is the load capacity, how much weight you were able to load onto your bridge without it breaking anywhere. And then the dead weight of the bridge. So you're going to want to weigh the bridge before you start, so that you have that number. Just use an electric scale in one of the science labs or something. And then the ultimate load capacity is how much weight you can hang from the bridge. Most people will just use weights from the weight room or something. You can usually get a 1-pound weight in the weight room. It's pretty small. If you can't get that, then one of your science teacher probably has some free weights that you can add to it. A kilogram weight is 2.2 pounds, so you can start with 1/4 of a kilogram, 250 grams, and move up from there. Those are about a 1/2 pound. So you're going to want to calculate your design efficiency using those two numbers. You're going to want to use the total. You're going to want to calculate the total length of the materials used. You're going to want to write a 1-page report about your bridge design process, revision, aesthetics, and this is where you would include pictures that you have taken here. You're going to include all these things that are kind of these engineering terms, this nice list of terms here. But at the end, you have the project evaluation rubric, where you're going to give yourself a grade, and I'm going to give you a grade. You're going to be grading on meeting design criteria that we've mentioned already, the performance, the aesthetics, craftsmanship, student participation, drawing sheets, and your report. You're going to give yourself a grade for all those, and then I will see what I think of all of those. And that is really the next part of this project, and the last part of this project. So, things that I want you to remember: take pictures during your building process. Make sure that you do the design process completely. Take big pictures during the building process. And then when you actually do the test, I want you to make a video of each test that you do. So set up your bridge, you're going to measure the height from the floor up to the bottom of the bridge, and then you're going to put some masses on it. You're going to watch how much the bridge bends. So you're going to have your yardstick there to see how much the bridge bends. And you're going to keep adding weight until it breaks, and that whole process there should be a video of that you can send to me. And then we will be done with our first project, and on to bigger and better things. So that's a whole lot of stuff that I just threw at you all at once. Do you have any questions about that? Okay. Yes, I believe that I do have a few of those. I will look through my files and find one. If I can't find one, I will draw one and then send it to you. I will do that. You're very welcome. Anything else? Okay, make sure that you email me if you have any questions during the final phase of this project. We'll try to get all this turned in by Monday-ish and review any of the things that we need to review at that point, and then we'll move on in the syllabus. I think our next, I think we're going to go into chapter 5 for a couple days, and then we'll do another project. All right? Have a good one.